I'm Sara Seager, an astrophysicist and a professor at the Massachusetts Institute of Technology. Welcome to my exp. When we go outside and look at the night sky, we can see dozens or even hundreds of stars. But our Milky Way galaxy alone has hundreds of billions of stars. And our universe has upwards of hundreds of billions of galaxies. So if we just think about all of the stars out there, it's such a huge, tremendous number, it's almost incomprehensible. Now we know that every star is a sun, and our sun has planets, Mercury, Venus, Earth, Mars, etc. And so other stars should have planets also, and they do. And we astronomers have found thousands of planets orbiting other stars, other suns. So with the hundreds of billions of stars in a galaxy and hundreds of billions of galaxies, there are just untold numbers of planets out there. And the universe and the numbers of stars and planets is so vast, so full, it is almost incomprehensible. The stars are incredibly far away. Even our very nearest star, Proxima Centauri, is over 4 light years away. And each light year is about 6 trillion miles. So our nearest star is over 20 trillion miles away. It's so incredibly far. We can think about this in terms of our spacecraft. There are spacecraft that have traveled past our solar system. The Voyager spacecraft are traveling at about 20 kilometers per second. So you might ride a bicycle at 20 kilometers per hour, but this is per second. So although these spacecraft are moving quite fast, they would take tens of thousands of years, nearly 100,000 years, to get to the nearest star. So the fastest that we humans can make a spacecraft go couldn't reach the nearby star in any reasonable amount of time. So the stars are incredibly far away. The universe, our little corner of our galaxy, our neighborhood, is incredibly spread out, and the distances are huge. Well, 1,000 or 2,000 years ago, the skies would have been tremendously beautiful without the polluting lights we have now from our electric lights in our cities. And surely there were people back then who kept track of the stars, who monitored the position of stars and of the planets in our own solar system, Mars and Jupiter and Saturn, which move across the sky in a pattern that's very different from the regular stars in the night sky. So someone with a passion for astronomy who was lucky enough to be able to get a job in that area would have been someone who monitored the stars and the planets we can see and looking for anything unusual. And there were people who, people generally used the stars to indicate seasons when it was time to plant. They used the stars for navigation. And the few people who had a job in astronomy were actually astrologers. And they used the stars to help predict your horoscope or when a good time might have been to start a war or do something bold. Back then, there was no way to make precise measurements of the motion of stars or to know about galaxies or anything that required magnification of the night sky. The main way that we find planets today is by a method we call transits. Imagine a star out there with an unseen planet going in front of the star. So the planet and star's orbit is fortuitously aligned. It's aligned just so the planet goes in front of the star as seen from Earth. Now, we can't see the planet, and the star is just a point of light. But we can measure the brightness of the star. And if there by chance is a planet that goes in front of the starlight will drop by a tiny amount, related to the planet-to-star area ratio. And furthermore, when the planet goes in front of the star, each time the planet orbits the star, it will go in front. So we can look for a repeated drop in brightness. And today, we monitor tens of thousands, hundreds of thousands of stars simultaneously. And we use sophisticated computer algorithms to assess the brightness of each star as a function of time. And our computers look for a tiny drop in brightness that might indicate the presence of a planet.